All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're saying let's find our centroid of our object that we're showing here. We have a square with a half circle cut out of the top. So how are we going to come and solve this one out? We don't, in our centroid tables, directly have this. We don't have a square missing a half circle up at the top of it. We can still combine objects together. I could really say, hey, you know what? There's a positive square right here. Let's call that shape 1. And up at the top, we've cut out a half circle from that. Shape 1, if I treat it as a whole square, covers up some area here that's not really there. I can just come in and treat that top as a second shape. Shape 2, and I subtract it out from everything. A positive area and a negative area in there will give me my answer solved out. So I can break this into two pieces and come in and make a centroid table. You can make a table for centroids. It makes our work so much easier to follow. Makes it kind of lay out exactly like we would if we were building this into Excel. I need a column for my areas, the numbers, area numbers. And I'm going to move that down just a little bit so I'm not hitting all of my diagrams. So I need an area. And I'll get a column here. I need one row for each of my pieces. I have two pieces. So 1 and 2, 1, 2, and we need to sum a few things up. So I'll put a summation row. The next one, I'm going to need, what's the actual area in this? Let's write down our centroid formulas really quick. Our formulas we should be using are x bar is the sum of my x tilde a divided by my total area. And y bar is the sum of my y tilde a divided by my total area. So I'm going to fill in each of these pieces into my table. I need an area column in that. Every variable should have a column in here. So an area. I'm in inches for my units. So I should be in square inches when I actually set that up. Then I have x tilde and y tilde. Let's get a column for each of those. X tilde in inches. And y tilde also in inches. And then we can multiply our area column by these two to get an x tilde a in inches squared times inches should get us cubic inches. And finally, a y tilde a, also in cubic inches. And that would be our setup piece in here. So let's go ahead and just fill in this table, and we'll have our problem knocked out. So the area for shape 1, it's a 5 by 5 rectangle. If we write our numbers in to show our work, 5 times 5 is the area. We're getting 25. For our semicircle, we're cutting this out from our shape. Shape 1 covered up this negative piece up here. So I need to subtract it out. So a negative area, negative pi times our radius. What's our radius of this? Well, if I know this goes from one edge to the next, I would know my diameter is 5 inches, so my radius should be half of that. It's 2.5. We're actually given the radius in here. Pi times r squared, 2.5 squared, divided by 2. Or this is negative 9.82. 25 minus 9.82 gets me my total area is 15.18 square inches. Then we can come in and get our x tilde values. So I'm going to measure from the y-axis, and I need to get to the centroid of each piece, which should measure, let's put a dot where those are loosely at. For our rectangle, it'd be right in the middle, halfway in and halfway up. It'd actually be right here. And for our semicircle, we know we are in the very center, perpendicular to our flat side. So the flat side's here. Our centroid will be on this line, straight down the middle. And it should be y bar, 4r over 3 pi n. So come down 4r over 3 pi. We're somewhere around right there for our second shape. So we're needing what's my distance from the y-axis to there for each of these. So for my rectangle, that'd be halfway in, 5 halves, 5/2 is 2.5. For shape 2, it'd just be the radius in, r, or also 2.5. And I don't need to add up my tilde distances in here. For y tilde, or my y distance to the centroid of each thing, some places would call that y bar 1, y bar 2. It's the same idea in here. But I would have, well, I measure from the x-axis, and I'll come up half the height. Would get me height over 2, 5 over 2 is 2.5. And for shape 2, it's a little bit trickier for us because I need to first get to where my centroid formula measures from. It measures from the flat side of the semicircle. So I'm going to have to go up 5 inches to get to that flat side. So 5. And then from the flat side, I'm coming back down 4r over 3 pi. So let's subtract that out. 5 minus 4r over 3 pi. Or 5 minus 4 times 2.5 over 3 pi gets me 3.94, which would be my next piece in there. Again, I don't need to add up my y tildes. But from here, I can come in and figure out x tilde a. 25 times 2.5 gets me 62.5. Negative 9.82 times 2.5 will get me negative 24.5. And I do have a sum of my x tilde a in my equations. Let's add this up. I get to 38. For y tilde a, 25 times 2.5 is still 62.5. For y tilde a for our second shape, we get 3.94 times negative 9.82. Don't drop this negative. It's a really common mistake. I should have said it here too. But to drop our negative, to correctly find the area, and then to do 9.82 times 3.94. Remember, it's negative area. Negative 9.82 times 3.94 should get us a negative 38.7. And if I add that up, 62.5 minus 38.7 should get me to 23.8, which would be our final piece on our table. And that gives me enough that I can come in and find centroids. That my x bar should be, before we even check that, logically, if x tilde, the centroid of every piece in this object, is at 2.5, x bar should end up being there too. That's what we're going to see. Our x tilde a, 38, divided by our total area, 15.18, is going to get us that x bar is 2.5 inches. If every piece has its centroid at the same place, the whole thing has its centroid at the same place. Y bar should be equal to our total y tilde a, 23.8, 23.8, divided by our total area, 15.18, or that y bar is going to get us to 1.57 inches, which would be our final answer for everything on that problem. As you're tackling centroid problems, take a second when you get numbers out and just ask yourself, does this logically make sense? Does it logically make sense that my centroid here is in the dead center? It probably does. Does this seem reasonable for my centroid? While 1.57 up in the y direction. I would say it does. If the entire thing were solid, my y bar would be 2.5 if it was just a square. I've cut out a good chunk of the top of this. It makes sense that my centroid should shift downward some. Dropping about an inch doesn't seem unreasonable to me. Even though I couldn't immediately just say, oh, it's 1.57, I can say logically that answer does make sense for us. Also, big picture, think about your answers. I've given problems like this on a test before and had people tell me, oh, that y bar location is like 32 inches up there. That logically should make zero sense for anything. If the entire object is a 5 by 5, that centroid should fall within the bounds of the greater object there. I can't have my centroid being way past everything in there. Logically, that doesn't make sense. For my students, if they give me a nonsense answer like that, oh, y bar's 30 inches. I actually mark them down more harsh because we need engineers who can stop and critically think about things. And that shows an absolute lack of critical thinking. So stop and think about your answers. Does this logically make sense for everything? But hopefully this is a useful video for you. If it was, hit those like and subscribe buttons. Stick around, watch more videos. Let's get you an A with JJ.